There we are. Hey, it's me, John Park, and welcome to John Park's Workshop. I was having some weird audio difficulties, but now I think things are resolved. Checking in the chat over in Discord, and yay! Hey, Mr. Certainly. Thanks for checking. I don't know if you can hear this, but it's raining like crazy, which is a rare thing here in Southern California, and probably a good thing. We could use the water. But we are all safe and dry, I hope, and cozy here in John Park's Workshop, and Summersoft has JP in his ears now. Very cool. Let's see. Ooh, that's a little peaked. Let me drop that level a little bit. My secret weapon is C. Grover in the chat, who's probably going to tell me how my audio is doing. We are at, oh good, -2 dB peak. All right. The goal is to stay near but under 0 in the weird world of decibels and how those work. So let's see, we've got some cool stuff to look at and listen to today on the show. And what I wanted to do first is jump into some things, such as Help Wanted. Hey, we've got a Help Wanted board. Did you know that? Jobs.adafruit.com. I'll move out of the way of it. And there it is. There's jobs.adafruit.com. And you can see we've got this free job board. So if you are a potential employer looking to hire some fine folks to do maker-ish things and engineering types of stuff, this is the place to go. It's free, and you can post your job postings here, and you can also post your skill set if you're looking for work. New stuff, we've got a lead electrical engineer job in Brooklyn at a place called Quip. That's a new one I hadn't seen on there before. So please go check it out. There's lots of interesting jobs. We've got a lot of engineering positions. Gadget builder maker in Leesburg, Virginia. That could be fun at Tactual Labs. Go check out jobs.adafruit.com. What else did I want to talk about? Oh, guess what? This little thing called AdaBox, AdaBox 10. We still have, as of an hour or so ago when I checked, we had about 30 spots left, 30 subscriptions left. We started with 4,000, and that's very exciting. Almost 4,000 people who are going to be getting an AdaBox in the mail already. I think some people may have gotten it already, and if not, very soon. They have started going out. So please check out the AdaBox. You can just type in Google in your You can type in AdaBox in your Google. That should get you there. Or adafruit.com/AdaBox. And let's see if it's still saying we've got spots left. All right. Do I dare refresh that page? I won't. But sign up now and receive AdaBox 10. It's shipping in December. It's already started shipping. So that brings me to the coupon today. And the coupon today for 10% off in the store and anything other than gift certificates, subscriptions, and software is low pass. And that's something we'll be talking about and listening to later today, the low pass filter, among other cool things. So go check out all the good things that you can get in the AdaBox store. We have new products every week. One of the products that I'm going to show in a moment was a new product just like a week ago, or maybe two. And hey, Yannick. Yannick is excited to receive their AdaBox. Your first one. That's excellent. A little spoiler warning. I'm not going to spoil anything, but if you go on the Learn Guides, Adafruit.com, you will see that there's a new Learn Guide out for AdaBox 10. So if you get your box, or you want to check it out before you get your box and see what's inside and what are the projects that we've got, you can check it out. The main guide is live. We haven't publicized it that much yet. It just went live like a day or two ago. And that's to prevent people from getting spoilers if they don't want to know. But there have been a lot of hints on this one, so it may be hard to avoid. But that brings me to product of the week. And the product of the week this week is this handsome 3-volt panel meter, analog panel meter. I'm going to show you it live and working in a second because I'm tying everything into the next thing for the most part today. And so in the next thing, in the Make Code Minute, we're going to actually see it in action. But this is a very nice and large panel meter that will show you anywhere from 0 to 3 volts. And it is easy to use. It is easy to hook into a project. It's got some screw terminals with washers and nuts on the back, so you can just clamp a wire down onto there. And you can measure your voltage on projects. You may have seen there are a lot of cool projects out there where people have used these to turn them into clocks. I think there's in the Learn Guides, there is a project on using panel meters for clocks. And I would recommend you check that out if you're thinking about using panel meters to visualize cool stuff such as the time. So that is our product of the week. Let me find it on our site here so you can see. Let's see, there it is, the large 3-volt analog panel meter. It is $9.95. You can see it in action there, sweeping back and forth. And in this case, it's hooked up to a Metro, and the Metro is just pinging back and forth some analog voltages. I'm going to show you how to do that in a minute on your Circuit Playground Express. So I'm just noticing in the chat, again, welcome everyone in the chat over in Discord and also YouTube chat. Hello, hey, Henry Caballero from Peru, welcome. Mr. Certainly in our Discord chat said that the last 3 AdaBoxes have been very heavily hinted, and he can't complain. It makes it easy to recommend to others. Right on. Okay, so let's see. I think it is probably a good time to check out our Make Code Minute. All right, let's bring up the Make Code, and I'm going to bring up that little guy. So there's my green screen. I've got my panel meter, and I've got a Circuit Playground Express. I'm also using that cool case. I've noticed the case is great for sort of diffusing the light of the NeoPixels a little bit, and you get this sort of whole full color object and not just the little piercing dots of light. So I like that little enclosure we have, designed by Mike Dole. So for today's Make Code Minute, I wanted to talk about sending analog voltages from the Circuit Playground Express using just a few blocks inside of Make Code. So first of all, you can see here on my panel meter that this gauge is moving down to about 0 and up to about 3. I've got it slightly off. I think I need to calibrate it. But you can see we're very smoothly sweeping analog voltages up and down. And the way I've done this inside of Make Code, you can see, first of all, in the onStart block, I've created a variable, and I've named it voltage, and I've set that to 0. And then I've also set the neopixels to a brightness level that's pretty low of 5, and I've made them all this magenta color. And now in the forever block, what goes on is we are waiting a second before we start, and then we have a little for loop that takes the voltage variable and ramps it from 0 to 1,000. Now the full range would be 0 to 1023, but I was going off the edge of the meter there because I haven't calibrated it. So it is a 10-bit, we get 1024 values of voltage being sent out of, in this case, pin A0. So the next thing I do is I write to analog pin A0, whatever the value of the voltage is, and then I pause just a tiny little bit of a moment. Then I set the, I do this 1,000 times. So we're ramping that volume up, or 1,001 times actually. Then we go to blue on the CircuitPython Express. We wait a second, and then we ramp it back down. Now, the way I'm ramping it back down, you'll see this is a little more complicated. I'm taking the analog pin, and I'm mapping that voltage variable that goes from 0 to 1,000, and I'm just reversing it. So this math node of the map takes that 0 to 1,000 and turns it into 1,000 to 0, which is what drops it back down. And that is how you can smoothly sweep through an analog voltage on the Circuit Playground Express using Make Code. That is your Make Code Minute. Okay, so I just noticed in the chat, Jeff Meeks says those little meters are awesome, so old school, want some in Eurorack form. Yes, indeed. In fact, I love meters, and here's one of the meters I have. This one I have actually plugged into, it's a box meter. It comes in an enclosure. It's an old school one, I think from the 1920s or 30s. And C. Grover in our chat was helping me. He actually came out with a little circuit board. I'm going to do a little more about this, and think we'll publish some stuff about it sometime. This little circuit board that allows a trinket to work very nicely with the panel meter and incoming control voltages. So I'm actually using this on my Eurorack synthesizer to visualize things like an oscillator that's moving back and forth, like a, what's the word I'm looking for? A LFO, low frequency oscillator. So anyway, panel meters, super great, and they can be adapted to show you lots of stuff in a very easy to get way compared to things like digital meters sometimes, or lights and colors. So it's just very, very nice to look at. Look at it there, it's beautiful. So that is our little product of the week in action on a Circuit Playground Express. Actually, one other thing I'll show you, let me make this big for a moment, is the, hi, that's me. The setup I've got here, I'm actually using that little camera 1/4 inch turn threaded insert tripod mount that's on the back of the Circuit Playground Express. I used that just to screw in this little adapter, and that brought the Circuit Playground Express up to the same height as the panel meter as I set it there. So I'm finding that case to be super great, and I think it's like $5 in the store. So definitely check it out if you use Circuit Playground Express. The buttons are still available, the switch is still available, and I like it a lot. So let's see. Now that brings us to our project of the week. Oh, cool. 8031 Brown in the Discord chat says they have a panel meter made in the factory where his dad worked in West London in the 1950s. That is very cool. I love vintage stuff, and that has a great story attached to it. That's very cool. Hey, look, it's me twice. Let me get rid of the second me. Goodbye. All right. Well, this takes us to our project of the week. And what I have this week is a Trellis M4 project. Huge surprise there, right? But it's the Trellis M4 season. I have a Trellis M4 project. Let's see if I can show it over there. There you see it, getting ready to be demoed. I have the Trellis M4, and the connections I'm using are so that we can bring in audio and send out audio. So I'm going to show you how we're doing that, because the Trellis M4 just has a single TRRS 3.5 millimeter headphone jack on it, the type you find on an iPhone, for example, that has tip ring sleeve, so it can bring in the earbud mic and send out stereo audio. So that is the only audio connection that looks like one. However, the stemma connector on the Trellis M4 allows us to use it in a lot of different ways. So what we're using it for is actually to read in on 2 analog pins on the M0, or rather M4 chipset that we have on there, the Atmega ATSAM-D51. So we're able to use the stemma connector to read in audio, and then we're going to write out audio over the sort of more obvious headphone jack on there. What we're using this for is to do a couple things. One, we want to visualize audio, so a VU meter that bounces sort of thing, that gives us different frequency ranges and the powers or volume levels in those different frequency ranges. And we're also going to use it as an audio filter. So we're going to do signal processing inside of the Trellis so that we can run a couple of types of filters on the sound coming in. So one kind of filter we'll use is a low-pass filter. All that means is that the filter cuts off harmonics or frequencies actually above a certain threshold. And then we'll also use a band-pass filter, which is similar, but we're dialing in a band of frequencies that we allow to pass through in a middle range. You'll hear this effect used a lot in dance music and in clubs and songs, and it's usually where you hear things get like muffled, like that's when you've got some kind of a low-pass filter and you're only letting some like really low-end stuff get through. So we're going to use that. Now, the reason I'm still standing here and not over there demoing it is that I first wanted to show you, this is actually a little tease for something I'm going to do next week, and that is this audio system design tool. Bring that up. This audio system design tool is from PJRC, Paul Stoffergen, the good people who bring us the Teensy. They created this audio library, which is now, the Teensy audio library has been ported to the Trellis M4, and so that's what we're using both for the visualization and for the filtering. So if you look here, this is this cool Node-RED interface that you can use to sort of patch together your audio DSP workflow. So this is one stereo input that can be routed. I don't have it routed here right now because we're actually changing the routing inside of software in our program. But you could ostensibly take the output of the audio that's coming in. That node could go to a filter. And if we open up this little cheat sheet on the side, it shows us this is a finite impulse response filter, or FIR filter. And then what we can do with this finite input response filter, impulse response filter, is tell it which sets of frequencies to let through. So we can use it as a low-pass filter, we can use it as a high-pass filter, I assume. We've got it in this case as a band-pass filter, which is a subsection of the possible frequencies going through. And then we're also sending the output of the filter. So we're filtering the audio, and then we're sending that to this FFT, a fast Fourier transform. That is the wad of math that allows us to do a visualization of the frequencies. So it can pick out the component frequencies of this mass of music that's coming through and visualize the different frequencies that we're hearing on our NeoPixels in the Trellis M4. So that is part of what happens here. I'm also going to show you, this is some of the code. Oh, let me hide that. I'll move out of the way of the code. This is some of the code. I just have it up in Atom here, but this is actually an Arduino program that has a bunch of additional bits of code that are used. You'll see in the project. I'm going to make a guide for this. This was all created by our good friend Dean Miller, and here you can see those same bits of nodes that I had over in the GUI design tool. You actually export those, and then you can drop them inside of Arduino and then make the connections and do more things with them. So that's all I want to show about that. We're going to get more into that in the guide and in future projects. But now I think this is a good time to demo how this actually looks and sounds. So why don't we jump over to the bench, hide this thing. Where's that thing? There's that thing. And we'll pop that up actually big, and we'll put the bench in the corner. Where are you, main cam? There you are. All right, let me head over there. Now, what I'm doing is, let me see if I can zoom this in a little bit further. If we have a look at the inputs going in, here's the Trellis M4. I've got an audio cable that I've added a little bit of a circuit to it with a, this is a pair of capacitors and resistors that are essentially being used to center the incoming voltages around what the ADC converter on the Trellis M4 is expecting, and removing DC bias. So the circuit here, I've just kind of dead bug constructed it, so we're not using a breadboard or not soldering anything, and then plugging it into these connectors on the stemma port that goes into the Trellis M4. I'm just powering it with this cable, this USB cable here. And then this is my output. So this stereo cable is outputting to a just a little guitar amp. So what I'm going to do is, let me reboot it, just because it's been sitting in a while. I don't know what state it's sitting in. And I've just got a tiny little iPod Nano, old school-ish, and I'm going to play a song on here. I actually had a song from our good friend Colin Cunningham called Leather Apps that he wrote that has a nice, I think it sounds good on this demo. So what I'm going to do is I'm just going to play it, and I'm going to hold this button down so that we get the full frequency through, and you'll see the visualizer at work. All right, I'm just going to ride the volume down a little bit. So now what I'm going to do is I'm going to release this, and it's going to allow the filter to happen. And there's two filters. I'll use this button above to switch between band pass and low pass. So that's low pass. And you can see the visualizer is only lighting up in this lower section here. Now here's the full frequencies again. Low pass. Now here's the band pass. And you can hear that just cut out a lot of the low end. Low end. Band pass. And full frequency. Get ready. So it kind of acts like a terminator switch, cutting out the audio, but it's just because I'm cutting off some frequencies. And once again, just that little band, that narrow band in the band pass. Now let's go try a different song. I probably can't play much of a commercial song without getting our video taken down, but let's play a little Push the Button by Money Mark because it's a freaking awesome song. Here we go.
Okay, yeah, okay.
Here we go now.
There's low pass. Full frequency, and band pass. All right, better stop that before the YouTube gets after us. And then I'm really playing these largely because I think they're cool songs, and they're what I happen to have on this Nano, which has like 4 songs on it. It can fit a lot more, but that's just what I have. Baldwin Brothers. Bionic Jam.
Better. Stronger. We have the
All right, I'll cut that off Again, I don't want our lawyers to have to deal with that, so let me just turn that down. So you can see it's actually a pretty fun little interface. Let me put that back in the corner there. Where'd it go? Come back thing. There it is. A pretty fun little interface just for toggling on and off filters. And you can imagine taking this script, you can add a lot more filters, a lot more effects using the audio system design tool, and then use these buttons to add in different effects, delays and reverbs and so on. So this is really just kind of a sample of what you could do as a audio processing and effects and filtering device that also happens to just look really cool. So you can just port your audio through here and leave it looking cool. You might want to reverse the button so that it passes it through until you come up and hit an effect, or just use it as a launching off point to kind of create anything you want that will allow you to filter audio as well as visualizing it. So super cool project. I'm excited to put together the rest of the guide for you so you'll be able to go and check it out and start playing with it yourself. And one of the things that we've been doing lately, I'm sorry, I'm going to pause this. Oh, I'm just pull that out. There we go. One of the things that we've been doing lately that I think is really helpful with these projects is putting out a firmware, a UF2 bootloader, so that you can simply double-click reset on the Trellis M4 and then drag the UF2 file onto it, and boom, it's ready to go. So you don't necessarily have to compile and upload through Arduino. And we use the same process for how we put CircuitPython on. So I think a lot of people are getting used to this notion of just dragging on a UF2 flash file and then it takes it out of the bootloader and starts the program, whatever it is. So I will include a UF2 file that allow you to just get started immediately, drag and drop. I think the first projects that I noticed that we were doing this with were from Phil B with his eyeball projects on the Halloween. He has some UF2s that you can just drag on and try different eyeballs without even having to have the Arduino IDE installed and the boards and the libraries and so on. If you want to go in and tinker, and I hope you do, and change things and create your own versions of these that are highly personalized, then you definitely will want to have all that good stuff installed, Arduino IDE, the libraries, the board definitions, so you can compile and upload. But it's kind of nice that we're now in this mode with these microcontrollers that they have the flash storage on there, they have the bootloader built on, so we can click the reset button and get into a bootloader and drag on a file. So I'm excited about that. All right, so that is our project of the week, the visualizer and filter for audio. I'm going to hop back over here for a second, and where am I? Hi, that's me. Let's see. No, not tools and techniques. I know this. Let's talk about our coupon code again. You can head to the store and you'll get 10% off of everything in your cart other than gift certificates, software, and subscriptions using this coupon code LOWPASS. And that will get you 10% off on all the good, cool things. I think the Trellis board may be in stock. I don't think the case is, but at least as of last night, the board itself and I think the elastomer button pads were in stock. And if not, we are making them as fast as we can. They're flying off the shelves. People love the Trellis M4. I'm very excited to see the projects, the really creative projects that have been coming online, people using it. Over in the chat, 8031 Brown was saying he's having fun playing with the 8-step drummer on his Trellis M4 today. Simple thing, but so much fun. Absolutely a lot of fun. So I'm going to just check out the chat for a little bit. If you have any questions, let me take this coupon code out of my face. Go away. We just have a couple minutes left, and we'll see if anyone has any questions or thoughts or comments in the chat. I'm going to move this over here, and let's see. There's the Discord. It's kind of small, probably a little small for you to read. Sorry about that. Let's see, questions. So Dastel's asked about the implementation of this. I think hopefully what I explained, that this is using the audio library that was ported to the Trellis M4. That is the sort of foundation of the implementation of being able to do this. All riding on this incredible work that PJRC did for the Teensy. that makes audio, working with audio and DSP on these boards so easy. Really incredible stuff, and it's a real fun tool to work with. Let's see, does the SAMD51 port make use of the DSP support in the chip? I do not know that. I don't know if we have anyone on the chat right now, if Lady Ada or anyone else listening knows the answer to that, if we're using DSP support on the chip. I do not know, but I will try to find out, and I'll post here later. Yannick has an idea of using the Trellis as a memory game for his daughter, or an overcomplicated Simon game. That's excellent. Please do, and please share it. That sounds really great. Let's see, other questions. How are the UF2 files made? So Cascade asks this, and I thought, okay, we must have some tool or something. Just a few weeks back, I hadn't made any of them. I was like, what are we doing to make these UF2 files? As it turns out, the UF2 file is on the board once you've successfully uploaded your Arduino code to it. So you simply program the board as usual, upload it through Arduino IDE, and then double-click the reset button to put the Trellis M4 into bootloader mode. Then the Trellis boot drive shows up on your computer, and sitting right there is the UF2 file. It's called current.uf2. Drag it off, rename it something memorable for people. In this case, I'll probably rename it Trellis Visualizer / filter or something like that. And that is the UF2 file. So it's very easy to share that with people, which is very exciting. Is there a Learn guide for making those out? I don't think so, but we should add that to maybe one of the basic guides so that people can see it. But yeah, check it out. It'll work on, gosh, pretty much any of our Express boards. I don't know if that's the cutoff line for it, but pretty much any of our boards that you can double-click, or I think they're all double-click to get to bootloader, right? I'm probably not right on that. But if you have an Adafruit board that can go into bootloader mode and show up on your computer's USB drive by clicking or double-clicking reset, then you should be able to access that UF2 file to drag it off. Yannick says, that is such an easy way to distribute software. It really is. It's really terrific. And I think that both between being able to open up in a text editor a CircuitPython file, or if you have something more complicated or more involved that you need to share with someone, if you're doing support for someone remotely, the ability to say, here, take this file and get it onto this board after you double-click it is so much easier than, hey, install this IDE and these board definitions and these library files, and then pick through these menus and compile it. That is sometimes a bit of a nightmare for supporting projects remotely. So the idea that we can just give someone a UF2 file, very awesome. Love that. So thank you to everyone on our software development teams for making that possible, as well as for Microsoft. I think they're the ones who created the UF2 format initially, and it is what your make code, if you're using make code, that UF2 file is also what comes off of there, and it's how we distribute CircuitPython. Yes, Summersoft, great point. You can't mix board types, so that UF2 file is compiled for a particular board. So you would compile it for Trellis M4 and give it to someone. You might have a similar program that you've compiled for Circuit Playground Express and so on, but they are not interoperable. They're compiled per board. So, all right, that has been the show. Thanks for stopping by to John Park's workshop today. It sounds like the rain has let up, so I'm gonna be getting out of the workshop and going to work on that guide. So hopefully you'll be able to do your own modifications on the Trellis M4 visualizer and filter. Thank you all, everyone, for stopping by, and I will see you next week. Bye-bye. Thank you.